let's look out for. So use the same procedure I taught you. Let's continue. I want to finish today. Some factors that affect rate of chemical reaction. Rate of chemical reaction. Rate of chemical reaction. Some factors that affect rate of chemical reaction. Now we are going to consider 5 factors. I'm going to consider 5 factors. Now, temperature. Temperature has an effect on rate of chemical reaction. Temperature alters the rate of chemical reaction. So, for instance, if you are even cooking and you want the cooking to go fast, definitely when you increase the temperature, definitely it will go fast. And so, temperature plays a lot of role in the rate of chemical reaction. Now, number 2, concentration. Concentration or pressure also has an effect on it. When we get to this now, I explain it. Concentration also has an effect on it. Concentration or pressure also has an effect. It also increases it or pressure. I use the collision theory to explain all these things. Catalyst. Catalyst also has an effect. Introducing a catalyst also has an effect on it. It also increases the speed of the reaction. Surface area. The surface area also has an effect on it. That would be the particle size or the physical state. Also have the medium of it, whether it's light or this thing, can also have an effect on chemical reaction. So basically that is it. Now you just jump straight and go and do collision theory of reaction rate. That is what I'm going to use to explain all the factors. And so we are going to do collision theory. Collision theory. So this is collision theory of rate of chemical reaction, of reaction rates. Now, let me just explain it. The collision theory of reaction rates states that before chemical reaction takes place, the reacting molecules must collide. So before a chemical reaction must take place, the reacting molecules, that would have to do with the reactants, must collide. And so before chemical reaction can take place, the reacting molecules must collide. That's number 1. And let's take note that not all the collisions are effective. Some of the collisions are not effective. And so the ones that are effective, we have the ones that are effective brings about the chemical change. And so the first thing, let's understand that before chemical reaction must take place, molecules must react or must collide. Now, not all the collisions of the molecules are effective and thereby brings about chemical change. Only a small fraction of the collisions are successful in producing a chemical reaction. In there, they are trying to say that only the effective ones are successful in producing a chemical reaction. And these successful collisions are what we call the effective collisions. And so effective collisions are a fraction of total collisions of the reacting molecules that produce chemical reaction. And so if you are reacting to compounds or 2 molecules, definitely we have a lot of molecules in them. When they collide, not all of them will yield or will promote something called a chemical reaction. The few ones that promote or that enables chemical reaction are what we call the effective collision. That's what we call the effective collision. So the few collisions that enhance a chemical reaction is what we call effective collision. Basically, that is what it means. So effective collision we can now define as the fraction of the total collisions of the reactant molecules that produce the chemical reaction. So if you have, for instance, if you have about let me see if I can draw. If you have about 5, if you have about something like this, these are the molecules. So the first molecules are from molecule A. These are from molecule A. These are from molecules B, and you are reacting them to give a product. We believe that before it can undergo a chemical reaction, there should be collisions, and that means some of these must collide. Now, when all this collides, we are just trying to say that not all of them will be able to promote, after collision, be able to promote a chemical reaction. Some will would. the ones that will after if collision helps us get or undergoes a chemical reaction is what we call as effective collision. So that is it. It is collision with sufficient energy to overcome. You see, those ones they produce the ones that are effective. They produce a sufficient energy that is able to overcome the energy barrier in terms help us to produce something called the products. Only the most energetic molecules collide to bring about chemical change. So the most energetic ones. So the most energetic ones, or the most energetic collisions, bring about the chemical change. So only the energetic molecules collide to bring chemical changes. That means the weak ones, when they collide, it doesn't bring anything because they are not energetic. Only the energetic ones collide to bring chemical reaction. Now, the probability of collision occurring to cause a chemical reaction depends on the orientation of the colliding molecules. And so the probability of collisions occurring to cause a chemical reaction depends on the orientation. When we say orientation, it depends on the positions or how they are aligned. That will determine whether these collisions can bring us what we call it, or can lead to a correct chemical reaction. And so the probability of collision occurring to cause chemical reaction depends on the orientation of the colliding molecules. So how we orient them, how we position them, would also have a lot or play a lot of role in helping us get effective collision and thereby promoting chemical reaction. So proper alignment of the colliding molecules will help. Proper alignment, proper positioning, and so on and so forth. Now, we can ask that, state one reason why a collision may fail to produce chemical reaction. When the question is asked that, state one reason why collision may fail to produce chemical reaction, you can just simply say that a collision may fail to produce chemical reaction if the energy of the colliding particles is less than the activation energy, or if the reactants are not properly aligned. So we just learned that if the reactants are not properly aligned, that is the molecules, that's at the reactant side, if they are not properly aligned, we can't be able to get effective collision. Now, if the energy gotten from the colliding particles are less than the activation energy, we are not going to get chemical reaction, or a smooth chemical reaction wouldn't take place. Now, then I'm going to walk you through what activation energy means, or transition state theory. And so now, the transition state theory states that colliding molecules need a certain minimum energy. So colliding molecules, they need a certain minimum energy, amount of energy before forming activated complex. I also explain what activated complex are. And so the colliding molecule, so these molecules, when they collide, they need a certain minimum energy before they can reach something called activated complex. Now, this minimum energy, which must be acquired before chemical reaction to proceed, is called activation energy. So the activation energy, the word activate means to, you understand what activate means? To, should I say, to initiate. And so when we talk of activation energy, just explain from the theory of reaction, or using the collision theory of reaction, we are saying that there should be that effective collision, and that effective collision should generate a certain amount of energy that can enhance chemical reaction. So that minimum amount of energy that is needed or required to enhance an effective reaction is what we call activation energy. And so the activation energy needed to promote or to initiate a chemical reaction, or to enhance a smooth chemical reaction, or to proceed a chemical reaction is what we call the activation energy. So that energy that activates a chemical reaction is what we call activation energy, in simple terms. Now, this activation energy can be attained only from appropriate collisions. So we can only get the activation energy from appropriate collisions. That we call from only effective collisions, in other words. Now, we can now define activation energy as the minimum energy required by the reactants, because when you talk of the molecule, you are talking about reactants. Now, when reactants react and they form and they give us products, then we can say that a chemical reaction or a chemical process has taken place. Now, if nothing of that sort occurs, then that means there's no chemical reaction, or a chemical reaction hasn't taken place. So anytime I'm talking about the molecules, I'm talking about that of the reactants. So activation energy is defined as the minimum energy required by the reactants to cross the activation energy barrier for chemical reaction to occur. So the minimum energy that is required to cross the activation energy barrier for chemical reaction to occur. Now, when colliding molecules acquire activation energy, the reactant forms a complex molecule. So when the reactants or the colliding molecules, in other words, the reactants, when they acquire their activation energy, the reactant molecules now they form a complex molecule. It's homoiodine, so they form a complex molecule. Now, which possesses very high energy. So you bring your energy, I also bring my energy. When we collide, we can form a complex molecule or a complex, what do you call it, molecules. Now, when we form this complex molecule, because you brought your energy and I also brought my energy, now we become very strong. We become very strong. Then, as a result, please hold on, I beg. Oliver George. Yeah, it was. Afternoon was. So how will feed dog you? I don't feed dog you. Sorry, nothing that I teach online.